What is Java? What is the significance of using Java? Why was Java developed and who developed Java? Hey guys, hello, what's up? Welcome back to another amazing video of Technical Zone. You're watching Technical Zone and I am Umar. And now we are going to start with a new series in which I am going to teach you all Java, which is an object-oriented programming language and is undoubtedly very simple to understand. So without wasting any more time, let's quickly begin with this first episode of Java programming. The material which I'm going to use to explain Java theory is going to be the Computer Masti book of class 8, which is prescribed in the, which is used in some ICSE schools as well. So here is the material, and without a further ado, let's quickly get started. So before understanding Java, what is more significant is to understand that what is a high-level language, or for that matter, what is a computer language. Now, if I explain to you that what is a computer language, it is a mode of communicating between a human being and a computer system. A high-level language is a type of language, a type of computer language which makes use of words, maybe mnemonics, some numerals, and special characters as well. The use of all these characters and symbols makes programming easier. So, high-level language makes programming easier. And now we are going to understand that what are some of the features of high-level languages. So, let's quickly start. Features of a high-level language. The first one being concepts in a high-level language provide an easy and efficient way to write a program. Remember the keyword, easy and efficient way. With the help of symbols, characters, numerals, and alphanumeric codes, high-level language helps us to write codes in a very easy way, in comparison to that old traditional mnemonic codes which we used to write, which comprised of some capital letters and only numbers, or maybe in some cases that binary code which was coded in zeros and ones. High-level language is much more systematic and has concepts which make it very easy for us to understand programming, to learn programming, and to start coding. The second feature of a high-level language is it has its own syntax for writing programs. Now, like the human languages which we use, maybe Arabic, French, Urdu, Hindi, there are certain rules which need to be followed, which need to be kept in mind while we are communicating. In the very same way, high-level languages also have a certain set of rules, which means that they have their own syntax which needs to be followed while we are writing computer codes. Now, the third feature, a program written in a high-level language is referred to as a source program. So, for example, now I'm making a program A. It is written in a high-level language, then we will call that program a source program. And in some cases, we also call the source program the source code. Next, source programs are compiled. They are either compiled and or interpreted by the translator to machine language executable by computer. Now, long back we all studied that computers can only understand the language of zeros and ones, that is binary code. Computer is an electronic device. Like a switch, it can only understand the situation of on and off. We can only switch on a switch or switch it off. In the very same way, computer will understand only the on and off state of a switch, which is 0 and 1. And so, we need a compiler or a translator to convert the high-level programming language which has numerous symbols into binary code, which is actually the language which the computer understands. Next, a high-level programming language can be classified based on the approach as procedure-oriented programming language and object or object-oriented programming language. So in this video, what we are going to understand is mainly object-oriented programming language. And Java, which we are going to study in further videos, is a type of object-oriented programming language. Let's move further. COBOL, Fortran, Pascal, C, C++, and Java, ADA, LISP, Prolog, etc. are examples of high-level languages. So Java is also a high level language, which means that it will be very easy to understand. At the same time, we would be understanding it in a way which is quite fun. And you will think you are going to understand Java in a way which is very easy. Now let's move forward. As we got to know that high-level programming languages are of two types: procedure-oriented programming language and object-oriented programming language. Now let us understand that what are these types. First one being procedure-oriented programming language. The name is quite long, but actually the concept is very simple. So a procedure-oriented programming language follows a top-down approach in execution. A group of instructions which is organized into a function can be used. Data is accessed by functions. Example being C, Fortran and Pascal. Now, it says top-down approach. So it means, if we quickly use the whiteboard, it means that, for example, this is a program. So a procedure-oriented programming language is going to break this program into smaller bits. It is going to break it into smaller parts. And this is the approach which a procedure-oriented programming language follows. Example of a procedure-oriented programming language is C, and you can say Fortran and Pascal as well. Now, a group of instruction is organized into functions that can be reused. So let's say that these are the group of instructions. They are organized into a function. So this is a function, and these are, let's say this is instruction 1 and this is instruction 2. So a certain set of instructions are grouped into a function when we are talking about procedure-oriented programming language. Now, data is accessed by functions only. So for example, let's say I2 wants to access some data. It wants to access some data, let's say data D. It cannot access data directly. It can rather access data through this function only. And this is a unique property of procedure-oriented programming language. Now the next type being object-oriented programming language. Now object-oriented programming language is actually the reverse of procedure-oriented programming language. And the definition says that it follows a bottom-up approach and is based on the concept of objects. Objects are small segments of code that contain functions to perform a task on a given data. Example being C++ and Java. Now, according to the definition, whatever we studied right now in procedure-oriented programming language, object-oriented programming language is the total reverse of it. So, let's say that we have certain segments of code. Let's say that we are having two segments of code. The first segment being, in this second segment, let's say that this segment of code is 1 and this segment of code is 2. Now, these segments of code are put into a common structure. Let's say that this block is that common structure. Let's name it A. It is put into a common structure and functions can be accessed. Let's say that functions or the group of instructions which need to be run can be accessed through this block A only. So this simple diagram is actually of object-oriented programming language, which in short is called OOP. Yes, the short form is OOP, and Java is a type of object-oriented programming language. It is based on the concept of objects. Now, these small segments of code 1 and 2, they are nothing else but objects. These are those segments of code. These are objects which are grouped into one entity. Now, moving forward, programs developed in high-level languages are compiled into machine language using compilers. Compilers refer on the type of operating system installed on a computer. The machine code is then executed on the corresponding machines. Now, let us say that we are having a program. Fine. We are having a program and we are having a Windows computer system. We are having an Apple device and we are having a Linux. So let's say Unix computer system. So if you want to convert this program into machine understandable code, you want to convert this program into machine code, so we would be needing three different compilers. We would be needing three different compilers for these three different operating systems. And this, when this particular compiler is going to convert program, then only it can be executed on a Windows machine. If this compiler is going to convert the program, then it can be executed only on a Mac system. And let's say that if this compiler is going to convert the program into machine code, then it is going to be executed on this computer system. Let's move forward. Now, a compiler executes the entire program at once, while an interpreter executes it line by line. Now, I told you that the program which we write using a high-level language is called source code. So, we are having source code over here. Compiler and interpreter. Now, the difference is that compiler executes the whole program at once, whereas an interpreter will execute it or let's say it will run it line by line. First statement interpretation, then statement execution, then this process will keep on getting repeated. While in compiler, the whole thing is going to happen at once. Both have their advantages and disadvantages. Interpreter is going to tell any error which we are having in our program line by line. Compiler is incapable of doing that. So there are certain differences which we'll obviously cover in later parts. Now, let's move forward. Java, as I told you, is an object-oriented programming language. Now, before we dive directly into Java, it is very important that we understand that what is this object-oriented programming in detail. So we already got the definition over here of object-oriented programming language. Now let's quickly begin with concepts of object-oriented programming language. Basic elements of object-oriented programming in languages are objects, classes, data abstraction, encapsulation, inheritance, polymorphism, and data hiding. Basically, there are 7 concepts. And this is a simple diagram. Let's begin. Object. Now, an object is the basic element of object-oriented programming that represents a real-world entity. For example, car, bike, dog, fan, TV, remote, keyboard, etc. Maybe a chair, a table. So it is the basic element of OOP, or you can say that it is the atomic particle of a very big substance which is called object-oriented programming. And we can correlate it with real-world entities. Examples are given in front of you. Now, in the real world, objects have characteristics, or let's say that they have attributes and behavior. For example, a dog can be considered an object. It has attributes like name, color, breed size, etc. and behavior like barking, fetching, and waking. So this was an example of attributes and behavior in a real life entity. Now, similarly, a car is having certain attributes and behavior. The attributes being maybe the name, the color, the model, the price, and the year. The behavior being speed, mileage, start, stop, change of gear, and acceleration. Now, attributes and behaviors of real-world objects are referred to as data members and functions in object-oriented programming languages. Now, this is something which we need to store in our brains, because these concepts are going to be utilized later. So, attributes and behaviors of real-world objects are referred to as data members and functions in object-oriented programming languages. Let's move forward. Hence, we can say that an object contains data and functions. Functions contain the code to perform a task using the data of the object. For example, function mileage can be used to find the number of kilometers a car of a given model travels for 1 liter of fuel.
So basically, you can say that object is a container inside which we are having these data members and we are having functions. Function is basically that code which with the help of which we are going to perform certain tasks on the given data. So this analogy, I think, is the simplest to understand the relation between data members, functions, and objects. And this is the real world entity car, along with it its data members and the member methods. Let's move on. A set of related objects may exchange data and information through functions. Now, this is a very simple diagram. We are having three objects, object A, object B, and we are having object C. So they can share data and information with the help of functions. As I told you, function is the code with the help of which we perform certain things on the given data. And with the help of these functions, we can correlate objects and we can share data between different objects. Let's move forward. Now, polymorphism. Polymorphism basically it refers to the ability of an object to take different forms. In other words, it is a process of using a function for more than one purpose. Now, my suggestion will be to go with the second definition. I will suggest everybody to go with the second definition that says that polymorphism is the process of using a function for more than one purpose, because it is simple to understand this concept. Now, the next thing, that for example, a function called shape can be used to draw other shapes using different parameters. Let's go on the whiteboard again, and let's say that we are having a function f1. So if we are giving certain properties to this function f1, with the help of which now it can be used to make a circle. At the same time, it can be used to make a square. At the same time, it can be maybe used to make an ellipse. Then we will call that this function has been polymorphized. Now, by this I mean that this function can perform various tasks and it can be used for more than one purpose. And this is the basic concept of polymorphism. Polymorphism is very simple to understand. The second definition is something which I'll suggest everybody goes with, because you can easily understand the concept. Now, let's move forward. Features of an object-oriented programming language. We just now studied the features of high-level programming languages. Now, if we talk about these object-oriented programming languages particularly, then they are having 5 basic features. Let's cover them. Firstly, object-oriented programming, or OOP in short, is based on the concept of objects, as I already told. Secondly, in object-oriented programming, a program is developed into small segments called objects, where each object contains data and functions to perform the task. You can take this analogy. So, next, great emphasis is placed on the security of data. Data is hidden and can be accessed only through functions. I drew a diagram on the whiteboard which said that when we are coding using an object-oriented programming language, then data can be accessed only by the associated function. And when data can be accessed only by the function, then automatically it increases the security of data. It increases the privacy of data. It doesn't allow any data breach to take place easily. It reduces the frequency of data breach. Hence, object-oriented programming language is preferred more over procedure-oriented programming language. The reason being, security of data is one of the main priorities of these object-oriented programming languages. Next, inclusion of new data and functions is easier and reduces complexity. Now, for example, we have already made a code which is going to print numbers 1 to 10. And now we want to bring some modifications into it so that it prints not from 1 to 10 but rather till 1000. Then by changing a few words here and there, we can easily produce the change needed. And this is the reason people say that it reduces complexity and it is easy to maintain. Lastly, most common examples of object-oriented programming languages are C++ and Java. Java being the one which we are going to cover in further episodes. Let's get a quick overview of Java. What is Java? Who developed it? And let's quickly get a rough idea that what we are going to cover in upcoming videos. So yes, Java. It is an object oriented programming language which was developed in 1991. Not exactly 1991, it was maybe November or December of 1990 by James Gosling. Now, James Gosling is the person who actually developed a programming language called Oak. And he was assisted by his colleagues Arthur Van Hoff and Andy Bechtolsheim at Sun Microsystems to develop software for consumer electronics. Java was formerly known as Oak and later released as Java. The name was derived from the initials of the developers: J from James, A and V from Arthur Van, and A from Andy. Now, this is something quite controversial because people say that Java was also a coffee type in Indonesia, and the developers of Oak programming language, which is the old name of Java, used to consume this coffee during work, and this motivated them to change the name of Oak and to rename it with the word Java. And Oak, why did they name this programming language Oak? The reason being that the place from where they sat and used to work, in front, when they used to see from the window, outside there was an oak tree. So they named this programming language Oak. And Java was not made for computer systems. Java, which was primarily called Oak, was developed for set-top box project of Sun Microsystems company. This company made consumer electronics products, and Java was supposed to be one of their software which they were about to use in set-top boxes. And there's also a story that Android was also an operating system which was designed for actually cameras, film shooting cameras. But later it came into mobile phones, and yes, evolution happens. And let's move forward. So now we are having some features of Java. Now, features of Java. Let's go through the diagram. Firstly, Java is simple. Java is dynamic, which I have written over here, adaptable to evolution. Yes, Java was developed in 1991, but it is yet being used. It means that Java is evolving with time. Java is interpreted, meaning that Java makes use of an interpreter which is called Java Virtual Machine, which we are surely going to understand in upcoming videos. Portability. Java is machine independent programming language. The spelling of independent is wrong, I know. So this means that Java can be run on any computer system. It is not so that you are going to write programming, you are going to write a program on this computer system and later you cannot run that program on your mobile phone. No, that's not the case with Java. Java gives us high performance. It is multi-threaded. Multi-threaded over here means that a number of tasks can be made to get executed simultaneously, which increases the functionality of a program. And this is something very complex, but no problem, we'll surely cover it. Multi-threading in Java. Next, platform independent. Platform independent again means that Java, just a minute. Platform independent means that Java does not depend on any operating system. It can be executed on Mac OS as well. It can be executed on Windows operating system as well. At the same time, Linux or Unix. So the operating system never matters when we are talking about execution of Java programs. Java is also architecturally neutral. It is object oriented, which I told. Architecturally neutral. Now, architecturally neutral means that if we are producing some changes in the hardware, then it is not going to affect the Java program to a great extent. So it fits well, it blends well with most of the computer architectures. Architecturally neutral, you can say that it can work smoothly on a 32-bit system as well. At the same time, it will not create a problem while it is being made on run on a 64-bit system, and that's a good part. Next, distributed. Now, Java is distributed means Java splits the program to many parts. As I told you, Java is an object-oriented programming language, so it has many segments called objects. So automatically it's distributed. Java is secured. Now, because Java is an object-oriented programming language, and as we covered in the features of object-oriented programming language, that security of data is the prime concern of an object-oriented programming language. So automatically Java is a very secure language, and no doubt this is one of the reasons why people are yet using Java. Last, robust. Java has a very strong memory management system. With limited amount of RAM, Java can do many things. If we compare a procedure-oriented programming language to Java, then Java offers much more functionality than that programming language. Reason being, Java has a strong memory management. It can perform the same task with lesser amount of RAM. And that's also a good part, that weak computer systems, old computer systems with less memory can also run complex Java programs. Now, Java is a high-level object-oriented programming language. The compiler of Java first converts the source code into an intermediate binary form called bytecode, which is machine independent. Java interpreter, also known as the Java Virtual Machine or JVM, converts the bytecode into the machine code to run on a particular platform or the operating system. Now, as I told you, JVM or Java Virtual Machine is over here the interpreter, and we are also having a Java compiler. First, let's say that this is the source code. Now, the Java compiler is converting it into an intermediate binary form called bytecode. Now, this bytecode, this binary form is later being converted by the Java interpreter, or you can say the Java Virtual Machine, to machine understandable code, which is the Boolean logic, or you can say which is the language of zeros and ones that a computer understands. So though this entire chain of things happening over here may appear complex, yet they take place in a jiffy, and this is the reason Java applications get executed easily and quickly. So this is how the process of compilation of a Java program takes place. And yes, with this we come to the end of the first episode of Java programming, the first part of Java programming, in which we got to know a lot about Java, a lot of theory we covered. Next episode is going to be about the basic structure of a Java program. Where do we actually code Java, and how do we use some basic functions and tools in Java. I hope so you all liked this video quite a lot. If yes, then please do subscribe to this channel, like this video, and please do leave a comment that which video should we bring next. Very soon we are going to bring another amazing video. Till then, goodbye.